Hi everyone, my name is Supriya B. Welcome to my channel for math learning. Today I am going to introduce Chapter 4 Determinants of Class 12. In the previous chapter we have learned matrices and algebra of matrices. We have also learned a system of linear equations can be expressed in the form of matrices. Well, what is determinant? Determinant is actually a number associated with a matrix. Associated with a square matrix especially. Only square matrix having determinant. Let us consider a matrix A is equal to A1, B1, A2, B2. Then the determinant of this matrix can be expressed. This symbol representing determinant A, not modulus, or that means here determinant A can be written as determinant A is equal to determinant A1, B1, A2, B2 is a number that is A1, B2 minus A2, B1. Multiplying the elements in the main diagonal minus the product of elements in the other diagonal. A1, B2 minus A2, B1. Then determinant of a matrix of order 1. 1 means 1 by 1 matrix. So let P be a matrix . 3 is a 1 by 1 matrix. Then determinant P is the number 3. It has only one value, so that value itself is the determinant. Then if Q is another matrix, minus 5, then determinant Q is what? Minus 5 itself. Not, that means determinant minus 5, that is minus 5 itself. It is not modulus value. It is determinant. Determinant and modulus are different. So determinant Q is minus 5 itself. Then how we can find the determinant of a matrix of order 2? Order 2 means 2 by 2 matrix. Let A be a matrix 1, minus 2, 3, 4. Then determinant A is equal to determinant 1, minus 2, 3, 4. How we can find the answer? Yes, multiplying 1 times 4 minus 3 times minus 2. 1 times 4 is 4. 3 times minus 2 is minus 6. Minus of minus 6 is plus 6. So answer is 10. Then determinant of a matrix of order 3. That means 3 by 3 order matrix. Let us consider. First we can consider general example. Let A be the matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. Then determinant of the matrix is determinant A. Then the notation also is changed. Determinant A11, A12, let. Determinant of a matrix of order 3 can be expressed in terms of second order matrix. You can see how it is possible. That means we can expand this determinant along row wise or column wise. How many rows and how many columns are here? There are 3 rows and 3 columns. So there are 6 different ways of expanding a determinant. 3 are column wise, R1, R2, R3, 3 columns, C1, C2, C3, 3. Sorry, this is rows and these are columns. Usually we are finding or expanding a determinant using first row. So, see how we can find the expansion along first row. That means this is the first row. First element of the first row is A11. Then we will write minus 1 raised to 1 plus 1. This 1 and 1 represents the suffixes. First row, first element. Then deleting the row and column which contains A11. അതായത് ഈ കോളവും ഈ റോയും ഡിലീറ്റ് ചെയ്ത് ബാക്കി വരുന്ന ഡിറ്റർമിനൻസ്. That is A22, A23, A32, A33. Plus, then second element in the first row is A12. Then minus 1 raised to what? Yes, 1 plus 2. Then deleting the row and column that contains the element. So, first row and second column. The other elements are A21, A23, A31, A33. Plus, the third element is A13. Then minus 1 raised to 1 plus 3. Then delete the ഈ എലമെന്റ് ഉൾപ്പെടുന്ന റോയും കോളവും മാറ്റിയിട്ട് ബാക്കി വരുന്ന A21, A22, A31, A32. Then we know how to expand the second order determinant. So minus 1 raised to 1 plus 1 is minus 1 raised to 2, that is positive, so no need to write here. Then multiply A22, A33 minus, then multiplying along this diagonal A32, A23. Then here A12 minus 1 raised to 1 plus 2 means minus 1 raised to 3. Then the sign is minus 1 raised to 3 is negative, odd multiple, that means negative, so here it is negative. Then A21, A33 minus A31, A23. That is over. Then next is minus 1 raised to 1 plus 3 is positive itself, so here plus 1, 3, multiply A21, A32 minus A31, A22. So this is the general expansion. We can see one example. Evaluate. Like this we can do using column, first, second row, second column, third row, third column, like that. Then P is the or evaluate (1, 3, minus 1, 2, 4, 0, 6, 2, 1). See how we can expand or find the determinant of. So how we can along row wise or column wise, which is better? So row wise. So 1 into minus 1 raised. In the case we are doing problems, means no need to write minus 1 raised, because first one is positive, second is negative, third is positive, like. So 1 into, first I am writing 4, 0, 2, 1. No need to write always like this. 3 directly we can do. 3 deleting this 2, 0, 6, 1. Minus, here it is negative 1, so plus means negative 1 will come. 2, 4, 6, 2. And expand. 1 into 4 times 1, 4. Minus 2 times 0 means 0. Minus 3 into 2 times 1 are 2. 6 times 0, 0. Minus 0. Minus 1 into 2 times 2 are 4. 6 times 4 are 24. 4 minus 0, 0. 1 into 4, 4. 2 minus 0, 2. 3 times 2, 6. 4 minus 24 is minus 20 times minus 1 is plus 20. Here 4 minus 6 is minus 2 plus 20 or 24 minus 6. Anyway, we can find out 18 is the answer. If you are using first column also we will get the same answer. Second column if you are using we will get the same answer. So this is the determinant of a matrix of order 3. How we can find the determinant of a matrix of order 3? In terms of second order matrix. So some other questions we can do. Another example. Evaluate 1, 2, 3, 4, 2, 0, minus 1, 5, 0. Find the value of the determinant. Here it is easy to use the last column because the last column contains 2 zeros. Then we use last column means this is the element A13. So minus 1 that is positive. So 3 times 4 times 5 minus of minus 1 times 2. That is 3 into 20 minus 2 minus plus 2. 3 times 22 means 66 is the answer. One more example. Find the value of x for which determinant 2, 4, 5, 1 is equal to 2x, determinant 2x, 4, 6, x. Here, given that the two determinants are equal, we have to find the value of x. How? Don't get confused because in the last chapter, previous chapter, you have learned two matrices are equal, the corresponding elements are equal. Here it is not, these are determinants, corresponding elements are not equal. We have to expand and find the value of the determinant, then equate. Then how we can expand this? 2 times 1, 2 minus 20 equal to 2x into x, 2x square minus 24. Here 2 minus 20 is minus 18 equal to 2x square minus 24. So 2x square I am writing first. That means this one we are moving to this side. Minus 18 plus 24. What is the answer? 6. That is 2x square is 6. That means x square is equal to 3. Then what is the value of x? Square root of 3. That means plus or minus root 3 is the value. Possible values of x. Wasn't easy? Yes. Very easy to find the determinant of a matrix. It has a wider application in mathematics as well as in other fields. In this chapter itself, we are going to learn some application like that. Finding the area of a triangle, finding the area of a parallelogram, and solving a system of linear equations using determinants. And great especially, we can find the inverse of a matrix using determinants. In the previous chapter we have learned how to find the inverse of a matrix using elementary row or column transformation. That is a little difficult, or calculation is lengthy. Here we can find the inverse in a better way. So I think you enjoyed this video, and now that it is the time to do something by your own. You have to do the exercise 4.1, all the questions as homework. Okay. Okay, thank you for watching me. Hope you all enjoy this video once again. And the next video, I'm going to prepare for properties of determinants. Okay, thank you. A great day ahead. Bye bye.